The impulse response of a continuous time LTI system is as shown in the figure. We have to find if the system is causal and BIBO stable. From the impulse response, we see that h of t is 0 for t less than 0. From this, we see that the system is causal. We also see that as the impulse response dies out as t tends to infinity, integral minus infinity to plus infinity mod of h of t is finite. So the system is stable in BIBO sense. Now let us consider another MTI system of impulse response as shown. It's a continuous time system. We have to find or we have to comment on the causality of the system. Here we see that the impulse response h of t is not equal to 0, or rather say is equal to 0 for t greater than or equal to 0. From this we see that the system is anti-causal and hence non-causal. Now let us consider another LTI system of impulse response h of t, which is as shown. The impulse response h of t saturates to a value 1. We have to comment on the causality and stability of the system. Here we see that the impulse response is 0 for t less than 0. From this we can say that the system is causal. Also if we see integral minus infinity to plus infinity mod of h of t tends to infinity because the value of h of t saturates to 1. From this we see that the given LTI system is not BIPO stable. Now let us consider a LTI system which is represented by the LCCDE y of n minus half into y of n minus 1 is equal to x of n minus 2. We have to comment, and it is given that this LTI system is given an input of x of n is equal to delta of n plus 2. We have to find the output y of n for the given input. Please note that y of minus 1 is equal to 0. So upon substituting n is equal to 0 in the given LCCDE, we see that y of 0 is equal to half into y of minus 1 plus x of minus 2. We know that x of minus 2 is equal to 1 because it's given with a impulse input. So y of 0 is equal to 1. So upon substituting n is equal to 1, we get that y of 1 is equal to half into y of 0 plus x of minus 1. As the input is the impulse input, we know that x of minus 1 is 0. So y of 1 will be half. Similarly, if we substitute n is equal to 2, we see that y of 2 is equal to 1 by 2 whole square and so on. So we see that for n is equal to m, the output y of m can be written as 1 by 2 whole power m. From this we see that the response of the system for the input delta of n plus 2 can be written as 1 by 2 whole power n if it is n is greater than or equal to 0, otherwise it is 0. So we can write the y of n as 1 by 2 whole power n multiplied by u of n. So for the given input and for the given initial condition, as per the LCCDE of the LTI system, the output is 1 by 2 whole power n multiplied by u of n. Now let us consider a LTI system with impulse response h of t is equal to e power minus 2t multiplied by u of t. We have to comment on the stability, that is PIBO stability and causality of the system. We see that the impulse response h of t is equal to 0 for t less than 0. From this, we can say that the given system is causal. Also, we can say that integral minus infinity to plus infinity mod of h of t is equal to integral 0 to infinity e power minus 2t is equal to e power minus 2t by minus 2 infinity to 0. So this upon evaluating becomes 1 by 2. From this, we see that the integration in integral minus infinity to infinity mod of h of t is equal to 1 by 2, which is finite. From this, we see that the system is stable in VIBO sense. From this, we can say that the given LTI system of impulse response h of t is equal to e power minus 2t ut is causal and stable in VIBO sense. Now, let us list down the impulse responses of different discrete time LTI systems. We have to comment on the causality and stability of those systems. The first impulse response we list down is 1 by 3 whole power n u of minus n minus 1. In this case, we see that the impulse response h of n is 0 for n greater than or equal to 0. From this, we see that the system is anti-causal. We can also show that sigma n equal to minus infinity to plus infinity mod of h of n is mod of h of n tends to infinity if we try to find out the summation. From this, we can see that the system is actually unstable in BIBO sense. Now, let us consider another system of impulse response 1, comma 2, comma 0, comma minus 1, comma minus 2. Here the value 0 corresponds to the instant n is equal to 0. Here we see that there exists at least one n1 greater than 0 and one n2 less than 0 for which h of n is non-zero. From this we can say that the given system is non-causal. Also we can see that sigma n equal to minus infinity to plus infinity mod of h of n is equal to 6. So the given system is stable in BIBO sense. Now let us consider another continuous time LTI system which is of impulse response sine 2t. Here we see that h of t is not equal to 0 for both t less than 0 and t greater than 0. So from this we can see that the given system is non-causal. We can also say that integral minus infinity to plus infinity mod of h of t if found out tends to infinity. This is because sine 2t's values range between minus 1 to 1. So as the integration tends to infinity, we see that the given system is not stable in BIBO sense. Now let us consider a discrete time LTI system whose unit step response is given as yu of n is equal to 1 comma 3 comma 4 comma 0 where the value 3 corresponds to the instant n is equal to 0. From this, try to find out the impulse response of the LTI system. We know that the impulse response of the LTI system is given as hu of n is equal to yu of n minus yu of n minus 1. This can be written as 1 minus 0, 3 minus 1, 4 minus 3, 0 minus 4, where the value 3 minus 1 corresponds to the instant n is equal to 0. This upon simplification becomes 1 comma 2 comma 1 comma minus 4. So this is the impulse response of the given LTI system which is obtained using the formula h of n is equal to yu of n minus yu of n minus 1. Now it is given that there are two LTI systems of impulse responses H1 of n and H2 of n connected in parallel. It's given that h1 of n is equal to 1 comma minus 5 comma 3 comma 2, and it's given that the cumulative LTI system is anti-causal. So from this, we need to find out the impulse response H2 of n out of the options given. So it's given that there are two LTI systems of impulse response H1 of n and H2 of n connected in parallel. It's given that the cumulative LTI system is anti-causal. If so, we have to find the possible impulse response H2 of n from the options given below, where the option A corresponds to 0, 0, 1, minus 1, where the second 0 corresponds to the instant n is equal to 0. Option B is 1, 5, minus 3, minus 2, and option C corresponds to where minus 3 corresponds to the instant n is equal to 0. Option C corresponds to 3, 4, 1, minus 1, where the value of 3 corresponds to the n is equal to 0. Option D means none of these. We know that if two LTI systems of impulse responses H1 of n and H2 of n are connected in parallel, the cumulative impulse response can be given as H of n is equal to H1 of n plus H2 of n. So we have to find the correct impulse response H2 of n from the options given such that H2 of n is equal to 0 for n greater than or equal to 0. So if we pick the option A, and from this if we try to find H of n, we see that H of n is equal to, please note that the value of 3 corresponds to the instant n is equal to 0. We see that the cumulative impulse response is 1 comma minus 5 comma 3 comma 3 comma minus 1, where the value of 3 corresponds to the instant n is equal to 0. Here we see, because of the non-zero samples for n greater than or equal to 0, we see that the system is anti-causal. The system is not anti-causal, so A is not a correct option. Now, if we consider the system in B, we see that the cumulative impulse response H of n can be written as 1, 1, 0, 0, 0, where the first value of first 0 corresponds to the instant n is equal to 0, as H of n is equal to 0 for n greater than or equal to 0. We see that the system is anti-causal, so B is a correct answer. However, we will verify once if C could be correct. If we pick the impulse response in C, we see that H of n is equal to 1, minus 5, 6, 6, 1, minus 1, where the value of 6 corresponds to the instant n is equal to 0. As H of n is not equal to 0 for n greater than or equal to 0, we see that the cumulative system is not anti-causal. So C is not a possible answer. So we see that for the given H1 of n, if we pick the H2 of n in the option B, we see that the cumulative system of impulse response H1 of n plus H2 of n leads to a system that is anti-causal. From this, we see that B is the correct option. Now, let us consider a problem related to convolution. It's given that there is a continuous time signal g of t which is greater than 0 for t belongs to minus t by 2 to plus t by 2. We have to find the starting point of f of t and length of f of t if f of t is given as g of t convolved with g of t. We know that the starting point of f of t is given as starting point of g of t plus starting point of g of t, and length of f of t is given as length of g plus length of g. Here the starting point of g of t is minus t by 2 added with minus t by 2. This is equal to minus t. Similarly, here we see that length of g of t is t plus t. This is equal to 2t. From this, we see that f of t starts at minus t and of length 2t. Now, Let us consider another let us look into another problem where the impulse response of a LTI system is given as h of n is equal to 1 comma 2 comma 3 comma 4 comma 5, where the sample 2 corresponds to the instant n is equal to 0. We have to comment on memoryless property, causality, and stability of the LTI system. Here we see that the impulse response h of n is not equal to 0 for n not equal to 0. From this, we see that the system has memory. We also see that h of n is not equal to 0 for at least one n1 greater than 0 and for at least one n2 less than 0. From this, we can say that the given system is non-causal. We can also see that sigma n equal to minus infinity to plus infinity mod of h of n is equal to 15. So as the summation is finite, from this we can say that the given system is stable in BIBO sense. Now let us consider a continuous time system. Now let us look into another problem where the impulse response of a continuous time LTI system is as shown. Here we see that the impulse response is present in the range minus 10 to plus 10 second and it is of value 1. We have to comment on the causality and stability of the system. Here we see that the impulse response is non-zero for at least 1 and 1, for at least one t1 greater than 0 and for at least one t2 less than 0. From this we see that the given system is non-causal. Also h of t has finite support and its values are finite in this interval. From this we see that integral minus infinity to plus infinity mod of h of t dt is finite. From this we can say that the given system is stable in VIBO sense. Now let us look into another problem where it is given that the impulse response of a LTI system is given as h of n is equal to 3 power n into u of minus n minus 1 plus 3 into delta of n minus 3. We have to comment on the causality and stability of the system. Here we see that the impulse response h of n is equal to is not equal to 0 for n1 is equal to 3 greater than 0 and for n2 less than or equal to minus 1. From this we see that the given system is not causal and not anti-causal as well. Also we see that if we try to find out the sum sigma n equal to minus infinity to plus infinity mod of h of n, we see that the sum is finite if found out. So from this we can say that the given system is BIBO stable. Now let us consider another problem in which it is given that there is a signal x1 of n of length 5 and it is given that x1 of n is greater than 0 is convolved with another signal x2 of n to get a signal y of n of length 5. It's given that x2 of n is also greater than 0. So now we have to find out the length of x2 of n from this. We know that the length of y of n, that is ly is equal to 5, is equal to length of x1 plus length of x2 minus 1. So here we know that the length of y should be less than or equal to lx1 plus lx2 minus 1. But it is given that x1 of n is greater than 0 and x2 of n is greater than 0. So this inequality would lead to equality, that is 5 is equal to lx1 that is 5 plus lx2 minus 1. So from this we see that the length of x2 of n is 1. From this we can say that the length of x2 of n is 1. Now let us look into the problem in which the impulse response of a discrete time LTI system is given as h of n is equal to 1 by 2 whole power n into u of n minus 3 power n multiplied by u of minus n minus 1. We have to characterize the system based on causality, memoryless property, and stability of the LTI system. Here we see that the impulse response h of n is not equal to 0 for n less than or equal to 0 and for n greater than 0. From this we can say that the given system is not causal and not anti-causal. So we can also say that the given system has memory because the h of n is equal to 0 not equal to 0 for n not equal to 0. Now if we try to find out sigma n the absolute sum of h of n, that is sigma n equal to minus infinity to plus infinity mod of h of n, we see that this infinite sum is finite. This can be proved by finding the infinite sum for 1 by 2 whole power n and 3 power n u of n minus 1 separately. From this we can say that the given system is stable in BABO sense. Now let us consider another problem in which it is given that there are sequences xi of n where I is equal to 1 comma 2, that is there are two sequences x1 of n and x2 of n. It's given that xi of n starts from minus I and is of length 2i plus 1, and it is also given that xi of n is greater than 0 for, for every n and for every I. Now we have to, out of the four samples given, we have to find which of the samples is definitely not 0. The four samples given are y of minus 4, y of 0, y of 4, y of 6. We can say that x1 of n starts from minus 1 and is of length 3. Also x2 of n starts from minus 2 and is of length 5. From this, sorry, please note that y of n is equal to x1 of n convolved with x2 of n. This was not highlighted before. From this we can say that y of n starts from minus 1 plus minus 2, that is from minus 3, and is of length 3 plus 5 minus 1, that is 7. Therefore we can say that y of 3 exists in the range minus 3 to 3, and it is definitely not equal to 0 in this range because of the reason that x1 of n and x2 of n are greater than 0 for every n and I in the given range. So from this we see that y of n in this range is not equal to 0. So we can, out of the options given, we can say that y of 0 is definitely not equal to 0. Therefore the correct option is B. Now let us consider another problem in which it is given that the unit step response of a LTI system is given as yu of t is equal to e power minus t minus e power minus 2t plus 1 multiplied by u of t. We have to find the impulse response of the LTI system. We know that the impulse response of the LTI system is given as h of t is equal to dyu by dt, which can be written as 2 times e power minus 2t minus e power minus t u of t, because we know that the impulse response of the system h of t is dyu by dt. Therefore, 2 into e power minus 2t minus e power t multiplied by u of t is the impulse response of the continuous time LTI system. Now, it is given that the impulse response of a LTI system is given as h1 of n is equal to, sorry, this is another problem in which the impulse response of a LTI system is given as h1 of n is equal to 1 comma minus 1 comma 1, and it is given that another system of impulse response h2 of n is connected in parallel to above system, and it is found that the cumulative system is memoryless. Now we have to find the h2 of n, or the possible h2 of n for which the overall system is memoryless. We know that if two LTI systems of impulse responses h1 of n and h2 of n are connected in parallel, the cumulative impulse response is h of n is equal to h1 of n plus h2 of n. This can be written as 1 comma minus 1 comma 1. Please note that the instant the value first one corresponds to the instant n is equal to 0. So this needs to be added with another impulse response, that is h1, or rather say a1 comma a2 comma a3. But we definitely know that this is equal to b comma 0 comma 0, where the value of b corresponds to the instant n is equal to 0. So this is because of the reason that if the overall system is memoryless, the overall impulse response should be a impulse of form b into delta of n. From this we can say that a2 minus 1 is equal to 0, that implies a2 is equal to 1. Similarly, a3 plus 1 is equal to 0, that implies a3 is equal to minus 1. And we can also say that b is equal to a1 plus 1, it shouldn't be equal to 0 because it's an impulse at the instant n is equal to 0. That implies a1 should not be equal to minus 1. From this we see that the impulse response of the system which is connected in parallel h2 of n is equal to b comma, sorry, a1 such that it is not equal to minus 1 comma 1 comma minus 1. So this is the generic representation of the LTI system, or generic representation of the impulse response of the LTI system that should be connected in parallel with the LTI system of impulse response h1 of n. That is, h2 of n should be a1 such that it is not equal to minus 1 and 1 comma 1 comma minus 1. This is the impulse response of the system that should be connected in parallel.